So if you're a developer who's been working with AI, you already know how amazing it is to connect these models to real-world tools. But I'm guessing you've also hit that really frustrating ceiling, that hard limit on what your AI can actually do at once. Well, today, we're going to break down a super clever solution that was born from that exact problem. This quote right here, man, it just captures a feeling so many of us developers know. You're deep in the zone, right? You're connecting your AI to GitHub, to your databases, to all these custom APIs, and then, bam, you hit a wall. This one sentence really is the spark that started this entire project. You know, the promise of protocols like MCP, that's the Model Context Protocol, it's huge. I mean, it's supposed to be this universal bridge between our AI assistants and all the services we use every single day. But as we're about to see, the reality for developers is often, well, a lot more limited. So here's the core issue, right? The way a lot of AI clients are built, they force you to make a choice. It's like, okay, do I connect my AI to my code on GitHub, or do I need it to query my database right now? You often can't do both in the same conversation, which means you're constantly stopping, switching configurations, and it just completely shatters your workflow. And this is the aha moment, the big breakthrough. Instead of trying to cram more and more tools through this narrow little doorway, what if you could just change the doorway itself? What if you could kind of trick the AI into thinking it only needs two super simple tools, but those two tools could secretly unlock an entire universe of possibilities behind the scenes? And that brilliant idea is MCPware. At its heart, it's basically a smart traffic cop. It stands right in the middle between your AI and all your different tool servers, GitHub, databases, whatever you've got, and it just acts as a central router. The AI talks to MCPware, and MCPware figures out exactly where that request needs to go. Okay, so how does this actually work? What I love about this is how simple the logic is. Your AI client loads just two tools. One is to figure out what's available, and the other is to actually use a tool. When the AI makes a request, the gateway just grabs it and intelligently sends it to the right backend server. It's this elegant little trick. The AI gets access to this massive library of tools, but its own configuration stays incredibly simple. Of course, having a great idea is one thing. Building it is a whole other ballgame. The developer here chose to build this thing completely from the ground up, avoiding existing frameworks just to get total control. And that decision was absolutely critical. But it also meant facing some pretty serious technical challenges head-on. So the first big problem was just managing all these different backend servers. You might think, oh, I'll just run Docker inside another Docker container. But that nested setup can become a total maintenance nightmare. So instead, the elegant solution was to have MKeepWare run in its own container and simply get permission to talk to the host's main Docker system. This lets it launch and manage other tool servers as siblings, which keeps the whole architecture clean and way more manageable. So just when things were looking good, a really serious bug showed up. The gateway, it turns out, wasn't listening for shutdown signals from Docker. And what that meant was, every time you stopped it, it left behind these zombie processes, these lingering backend servers that would just sit there eating up system resources. In a production environment, that's a complete showstopper. And this right here is where building from scratch really paid off. The entire problem was a single line of blocking code. Think of it like this. It's like a person who's so focused on one phone conversation they can't hear someone else knocking at the door. The main loop was so busy waiting for input that it was completely deaf to Docker shutdown commands. The fix was to make the system asynchronous, to let it do two things at once. By using a non-blocking reader and a dedicated signal handler, MCPware could listen for input and listen for shutdown signals at the same time, which completely eliminated the zombie process problem for good. Okay, so with those technical hurdles cleared, let's talk about the payoff. How does this actually change a developer's day-to-day workflow? Because this is where the real power of MCapWare becomes so obvious. I mean, the difference is just night and day. Before, it was this constant juggle, always choosing which tool you needed for one specific task. After MCQuare, that whole problem just vanishes. You have one single unified setup. You can ask your AI to check a pull request on GitHub, then query a production database, then hit a custom API, all inside the very same conversation. The limits are just gone. And it gets even better than that. You can start organizing your tools into these logical groups. For example, you could have a development group with your GitHub and your CI/CD tools, and then a completely separate AI thinking group with tools for memory and reasoning. This keeps your whole workspace organized and efficient because you only load the tools you actually need for the task at hand. So, what are the big takeaways from this whole project? Building MCPware wasn't just about solving one developer's problem. It really provides a powerful blueprint for building more robust and scalable software for all of us. So here are the 4 big lessons. First, the gateway pattern is an incredibly powerful strategy. Instead of fighting a limitation, just route around it. Second, an asynchronous architecture is absolutely essential when you're managing multiple processes. It prevents bottlenecks and makes sure everything is reliable. Third, that Docker out of Docker pattern is a really clean way to orchestrate containers without all the unnecessary complexity. And finally, simplicity always wins. A simple API that hides all the complexity behind the scenes, that is always the better design. And the project is not standing still. The next big step is to add support for streamable HTTP backends. This is going to open the door to all kinds of real-time data flows and make the gateway even more versatile for a huge range of modern web services. And, the best part is, this is an open source project. So if you've been hitting those same tool limits we talked about, you can head right over to GitHub, grab the code, and try it out for yourself. The documentation has everything you need to get it up and running. And that really brings us to the final and most important question. This tool removes a major creative and technical roadblock for AI developers. So now that those limits are gone, what are you going to build?